over the course of the next week and a half, we are going to talk about series and whether we have series that converge or diverge, okay? And by the end of this, we're going to go through 5 sections worth of tests, whether a series converges or not. And that's only going to be halfway through the chapter, okay? Today, we're going to talk about 3 of them, and every day we'll just add 1 or 2 more. Yeah. So this is our last AP chapter. We're going to do a short chapter after this before spring break to get you ready for Calc 3. Those of you who are going to Calc 3, it should be a grade raiser. And then, but this is like our last AP chapter. Get ready for our final.
So after spring break, we're just done with all this stuff.
No, we're gonna.
Like late March.
Okay. A series is the sum of a sequence. Okay. And when I say the series, we are talking about an infinite sum. We are talking about an infinite sum. No. I know, that was our lesson yesterday that I was on for an AB.
Yeah, because we had. Did you check these?
Yeah.
Did you see the little?
Yeah.
So basically, the pilot was and she just like made a random mark on her homework. Like, couldn't have said that. I said, "Want me to make you mad?" She's like,
Now, if we don't go to infinity, then we have what we consider a partial sum. So the sum from k equals 1 to n, okay, n is some number, like we're actually stopping. This is called a partial sum. So we have an infinite series or a partial sum. How many of you will do roll for sure? Okay.
oh, nice. Maybe it's- But it's not like this. It's not sketchy. So.
Okay.
Oh, can I drop out of it?
Why?
Go lower. I heard you don't get all your money back.
That's not not really up to me. You'd have to talk to Mr. Cruz. And lose all of your money, I'm sure. Then you would, well, you're doing rolling. Okay, we'll continue. Okay, if the sequence of a partial sum of a series converges, then we say the series converges. If the sequence of a partial sum converges, then the series converges. So S sub n is our partial sum. And if that converges to S, then our series converges to S. Right now, that makes no sense. Write it down and I'm going to give you a specific situation in which we are going to use it in. Okay. Basically, what this is saying is if you can take an infinite series and write it as like a partial sum, we can take the limit of that partial sum towards infinity. Now, this can only happen with a very particular case. In okay, so here is our first series test. Okay, and we are going to apply this theorem right here. So if a series collapses to a finite sum, then it converges by the telescoping series test. Just write it down and write down this example, and I'm going to show you how this happens. If we can take a series and collapse it to a finite sum, and we can take the limit of that finite sum, then we're going to be able to show that it converges. By the telescoping series test.
Is that the partial, like the partial sum collapses to finite sum?
Like basically if we can collapse this to be, I mean, it's technically, we say it again?
I'm just confused as to how.
We're gonna like actually take this and write out its series, and it's going to collapse into one expression. Let me show you how. Now, anytime I ask you, does the following series converge? We're going to be able to give a yes or no, but you always need to tell me how you know, okay? In this case, we're going to use the telescoping series test, okay? But by the end of this, we're going to know like 11 or 12 different tests.
Sounds like a lot like layers and layers. Did they remember them all?
You're not going to have a problem with it. All right, are you ready? Do you have this written down? Okay, when we plug in 1, we get 1 minus 1/2. Plus, then we plug in 2. Plus, then we plug in 3. All the way Oh, hold on. We're gonna do a partial sum. So let's change that to n. Goodness gracious. Okay, what happens, people? 1/2 cancel, 1/3 cancel, 1/4 cancel. So we will cancel all the way up until this 1 over n. You see how that works? So our partial sum is 1 minus 1 over n plus 1. So now that theorem that we talked about that made no sense, we have taken our infinite series, we've written out its nth partial sum, and now we are going to take the limit as n approaches infinity of this partial sum. And what happened? What? Well, towards infinity. Oh, up here?
Yeah.
Okay, so if this 1/2 cancels out with this 1/2, this 1/3 with this 1/4, this 1/4 with this 1/4, when we keep going, whatever's in front of this is gonna cancel out here. And we took the limit, and this is actually what this series is gonna converge to. Okay, now, what? You always have to tell me how you know why it converges or diverges. Okay, now let's talk about how we recognize that we have a telescoping series. This is special because we can write the nth partial sum as like one cute little expression. Okay, we have terms that keep canceling out to where we're left with front end and back end. You see what I'm saying by that? Okay. All right, you have actually known one of our series that's for calculus. You remember what series? Geometric series. Okay, so we have a geometric series. If we have a number times a number to the n power, or a number times a number to the n minus 1 power. A geometric series diverges if this r value is bigger than 1, absolute value of it, or equal to. Converges if the absolute value of r is less than 1. And we can determine what it converges to by this guy right here. Pre-calculus.
Or something. This teacher asked me to count to 100.
That would not be. what this is. That'd be arithmetic.
Yeah, I did like one of the, so.
Yeah, you do like first term.
Yeah, because he counted to 100, counted all the numbers from 1 to 100.
So that's an arithmetic sequence. So geometric, this is my example to you here, okay? Oh, man, I can't get your picture. Okay, here I am, knee to the wall, right?
Yeah.
I'm going to cut my distance in half. I'm gonna cut my distance in half. I'm gonna cut my distance in half. Theoretically, am I ever gonna get to the wall?
No.
But really, am I gonna basically be to the wall? So can we measure the distance that I travel?
In like, in total.
Yeah.
Not kind of.
Well, that is an infinite series, okay? I can keep getting half the distance, half the distance, half the distance, half the distance. I'm not really gonna move much, okay? But we can actually put a measurement on that. You see what I'm saying there?
Yes.
Okay. Now, something that we need to keep in mind, and we're gonna work with this a little bit more tomorrow. This formula actually tells us what our series would converge to. Now, sometimes our series may begin at like 5 or 3 or whatever. So this first term right here is actually referring to the first term of whatever your series is. So if it begins at 1, plug in 1, that's what goes here. If it starts at 5, plug in 5, that's what goes here. Okay, so it says a sub 1, but it really means the first term. What are you sending to him? Write this down. Okay, is this geometric? Okay, here's our first term. What is R? What do we multiply each time? Okay, so we recognize a geometric sequence because we are multiplying by the same number over and over and over. So from term to term to term, we multiply the previous one by 2/5. What is so darn funny that is distracting you from this and distracting me from talking about it? You're not even supposed to be sitting there. Every day I have to tell you to get back to your seat. This is why I don't want you to sit together, because you distract me and the rest of the class. Get back to your seat and cut it out. We're seniors in high school. Let's act like it. And you're still smirking. Like, that just ticks me off. You don't even care that I'm upset. Is our common ratio, the absolute value of it, less than 1? So this converges. Geometric series test. Bonus, we actually can figure out what it converges to. Okay, our infinite sum is the first term over 1 minus R. Yeah, this, what we wrote down right here, this is what it would converge to. Okay, we can actually put a number on the infinite sum. So in this case, we have 3 over 3/5. So this infinite sum converges to 5. Okay. Like you walking to the wall. I'm not gonna get to the wall, but we can put a number on how far I walk. Okay. All right, the last theorem we're going to talk about, okay? If a series converges, then its limit towards infinity is 0. Okay. If a series converges, then its limit towards, the limit of the sequence. I'm sorry, I was not saying that right. The series converges, the limit of our sequence is 0. So we can use this to figure out if a series is going to diverge or not. Okay. The nth term test only tells us if a series diverges. If the limit of our sequence is not 0, then our infinite sum is going to diverge. Okay, so we can take the, is that called the contrapositive? Yes, it's called the contrapositive. Okay, I had to remember, now that's back from proofs back in geometry, right? Do you remember those? Syllogism, like it is 5 years, well, 4. It was 4 years ago. It was your 8th grade year.
Starting.
You gonna be teaching that next year?
Yes. Why does that suck?
Geometry is the worst math class.
And I'm gonna make it the best. I'm not going to that school. Okay.
No, did you say Calc? Is there Calc 4?
No.
Yeah, no, you said the Calc 3 was the hardest math class.
What? I was not allowed to use a calculator in Calc 3. I had to do everything without a calculator. Okay, now, do you notice, and I put it in capital letters, this is only a test for divergence. If the limit of our sequence is 0, then we know nothing. This only works for divergence. If the limit of our sequence is not 0, our series diverges. If this is 0, then we know nothing. And we have to go to a different test. Okay. So my suggestion to you, anytime you get a series, in your head, at least think about, is the limit towards infinity of our sequence equal to 0 or not? Okay, because if it's not 0, then you already know that it diverges. If it is 0, then you got to keep going. So we're going to do some examples. It's making you nervous. Also, you're going to be professionals at drawing the sigma by the end of this chapter. You're already there? Okay. Let's take the limit of our sequence. If we take the limit as n approaches infinity of n factorial over 3n factorial plus 2. Okay, there's really nothing we can do to rewrite this, but let's think about it. What is true about the degree of the numerator compared to the degree of the denominator? They're the same. towards infinity, this limit would be 1/3. Hey, guess what 1/3 isn't? It isn't 0. So this diverges because of our nth term test. Yesterday we were talking about sequences. So it could like oscillate. So it wouldn't have to like go to infinity, it could just oscillate. Why do you think it diverges? Could you give me a little bit more? What does? Okay, so we can do this one of two ways. Andre has pointed out that if we take the limit of a sub n towards infinity, it would be infinity, which is not 0. Or we can recognize that this is a geometric series. Thank you, Aiden. Okay, so either you can say the limit as n approaches infinity of 3 to the infinity, 3 to the n equals infinity, which is not 0, diverges nth term. Or you could say that this is a geometric series where r is greater than or equal to 1, so it diverges. The geometric series test. So one or the other.
Oh, it's one. I had it.
Some of them, no. And I'm trying to explain, we don't really have enough examples for me to be able to show you. But like this right here. Oh, I have it right here. Don't write this down. What's the limit of 1 over n as n goes to infinity? Okay, but this diverges.
Well, we just said it.
No, the theorem says if this is not 0, it diverges. If this limit is 0, it's nothing. We don't know anything.
Whoa.
What would we have to do on this one? Oh, Lopto's rule. What a great idea. 2n over 1 over n. So what's the limit? Not 0, diverges, nth term test. Okay, without writing this down, what would we use here? This is the geometric series test. Is the absolute value of r less than 1? So it converges. And if we wanted to know what it converges to, we're going to take the first term over 1 minus r.